Today, Chernobyl is almost like a ghost story. There are empty apartment buildings, abandoned schools, a hospital full of old gas masks, and a Ferris wheel that never got to be fully used. And in the middle of it all, there is reactor number 4, covered in concrete and steel. Like the Soviet Union tried to put a giant metal lid over one of the biggest mistakes in human history. But Chernobyl was not caused by one guy pressing one bad button. It was not just a random explosion, and it was not simply nuclear power gone wrong. What happened at Chernobyl was much scarier than that, because it was a chain of small decisions, bad design, pressure from above, confusing instructions, and people did not fully understand the machinery they were controlling. It was like building a dragon, putting it in a warehouse, giving people tiny instruction manual, and then saying, please test if the dragon behaves during an emergency. So how did Chernobyl really happen? To understand that, we have to go back to the Soviet Union in the 1980s. At the time, the Soviet Union wanted to look powerful. It wanted big factories, big dams, big rockets, big nuclear power plants, and Chernobyl was a part of that image. Officially, it was called the Vladimir Lenin Nuclear Power Plant, which is already a very Soviet name. It was built in Ukraine, near a city called Pripyat. Pripyat was not some gloomy wasteland. It was a modern city. It had apartment blocks, schools, shops, swimming pools, cinemas, and young families. A lot of the people living there worked at the power plant. To them, Chernobyl was not a horror story. It was a job, it was electricity, it was progress. And inside that power plant were several nuclear reactors. The one that exploded was reactor number 4. Now, nuclear reactors sound complicated, because they are, but the basic idea is simple. Inside the reactor, atoms are split apart. This creates heat, that heat boils water, the water turns into steam, and the steam spins a turbine. This all leads to the turbine making electricity. Basically, it's a very complicated way of boiling water. But the dangerous part is that the reaction has to be controlled very carefully. Too slow and the reactor doesn't make enough power. Too fast and the reactor can become very dangerous. So reactors use control rods. Think of them like brakes. When the control rods go in, they absorb neutrons and slow the reaction down. When the control rods come out, the reaction speeds up. That's a simple version. But Chernobyl's reactor had a very serious problem. It was an RBMK reactor. This was a Soviet design. It was powerful, could produce a lot of electricity, it was also cheaper to build than some other reactor types, but had dangerous flaws. One of the biggest was something called positive void coefficient. That sounds like a phrase invented specifically to make people stop listening, so let's keep it simple. Inside the reactor, water helped cool everything down, but if the water got too hot, it turned into steam bubbles. In many reactors, more steam means the nuclear reaction slows down. That is good. It's like a car that automatically slows down when the road gets slippery. But in Chernobyl's reactor, under certain conditions, more steam could make the reaction speed up, which made more heat, which made more steam, which made the reaction speed up even more. It's not a safety feature, it's a feedback loop from hell. It's like if your car accelerates when you try to brake, and the people operating Chernobyl were not fully told how dangerous this could be. Some of the reactor's flaws were treated almost like state secrets, because in the Soviet system, admitting a major design flaw was not exactly encouraged. The official attitude was basically, our reactor is safe because we said it's safe, which is not really how safety works. Now we get to the test. This disaster happened during a safety test, which is the most ironic sentence in history. Operators wanted to test what would happen if the power plant lost electricity, because even if a nuclear reactor shuts down, it still needs cooling. The fuel inside does not instantly become safe, it keeps producing heat, so pumps need to keep pushing water through the reactor. The question was, if outside power was lost, could the spinning turbine keep generating enough electricity for a short time to run the pumps until the emergency diesel generators started? That was the test. On paper it sounds reasonable. The problem was everything around the test. First, the test had failed before, so there was pressure to finally get it done. Second, reactor number 4 was already scheduled to shut down for maintenance, so they decided to test it during the shutdown. Third, the plan required lowering the reactor's power, but then the electricity grid needed power, so the test was delayed. The reactor sat at reduced power for hours, and this created another problem. A substance called xenon built up inside the reactor. Xenon absorbs neutrons, which means it makes the reactor harder to control. Think of a xenon like something secretly pressing the brake while the operators are trying to drive. By the time the test continued, it was late at night. A different crew was on shift. They were now dealing with a reactor that had been sitting in an awkward state for hours, and then things got worse. The operators tried to lower the power for the test, but the power dropped too low. The reactor almost stalled. This was bad because nuclear reactors do not behave like normal machines. You cannot always just turn the dial back up and pretend nothing happened. But the operators still needed to run the test. So they tried to bring the power back up. How? By pulling out the control rods. Remember, control rods are the brakes, and they pulled out far too many of them. At this point, the reactor was unstable. It was running at low power, it had xenon inside of it, many control rods were removed, some safety systems had been disabled or bypassed for the test, and the reactor design itself had hidden dangers. This is the part where in a normal story someone would say, maybe we should stop, but that's not what happened. The test continued. and at 1:23 in the morning on 26th of April 1986, the operators began the test. They reduced steam to the turbines, the pumps started moving slowly, less water moved through the reactor, less water meant more steam bubbles, and in this reactor, more steam bubbles could mean more power. The reactor started to surge. The operators saw something was wrong, so they pressed the emergency shutdown button, AZ5. This button was supposed to insert all the control rods and shut the reactor down, the big red emergency button, the thing you press when everything is going wrong. But because of another design flaw, control rods had graphite tips. When the rods first entered the reactor, the graphite tips briefly increased the reaction in that part of the core before the rods could slow it down. So at the worst possible moment, the shutdown button did not immediately calm the reactor, it helped spike the power. The reactor power surged violently. Fuel channels ruptured, steam pressure exploded upward, the reactor's massive lid weighing hundreds of tons was blown off, and then came another explosion. The building was torn open, graphite blocks caught fire, radioactive material was thrown into the air, and the workers in the control room had trouble accepting what had just happened. Because according to what they believed, this kind of explosion was impossible. An RBMK reactor could not explode, except it just had. This is one of the most chilling parts of Chernobyl. The people in charge did not immediately understand the scale of the disaster. Some thought a water tank had exploded. Some thought the reactor was still intact. Workers were sent into the deadly radiation without knowing what they were walking into. Firefighters arrived to put out the flames. Many had no idea the fire was radioactive. To them, it was just another industrial fire. They climbed onto the roof, they picked up debris, they stood near pieces of the reactor core. Some of them received huge doses of radiation. And nearby, the city of Pripyat kept going. People could see the glow from the fire. Some watched from a railway bridge. Children went to school. Families went outside. Nobody told them immediately that the invisible radioactive particles were spreading through the air. The evacuation did not start until the next day. When buses finally arrived, people were told it would only be temporary. Bring your documents, bring a little food, leave your pets, you'll be back soon. Many never returned. The Soviet government tried to control the story, but radiation does not care about government embarrassment. It spread beyond Ukraine, across Belarus, across parts of Europe, and eventually radiation alarms went off in Sweden. Not in the Soviet Union, Sweden. That's when the outside world realized something serious had happened. The Soviet Union could hide information from its own people, but it could not hide radioactive particles floating across borders. So why did Chernobyl happen? The simple answer is, a reactor exploded during a badly handled safety test, but the real answer is deeper. Chernobyl happened because the reactor had dangerous design flaws, because the operators were put in a situation they did not fully understand, because the test was pushed forward even when conditions were wrong, because safety systems were treated like obstacles, because the Soviet system punished bad news instead of listening to it, and because everyone involved thought they had more control than they really did. That's what makes Chernobyl so terrifying. It was not one mistake, it was a stack of mistakes, each placed on top of each other, until the whole thing collapsed, and the consequences were enormous. 2 workers died on the night of the explosion. More workers and firefighters died later from acute radiation sickness. Hundreds of thousands of people were evacuated or relocated. Large areas were contaminated. The exclusion zone was created, and Chernobyl became a symbol of what happens when technology, secrecy, and human pressure combine in the worst possible way. But maybe the most disturbing lesson is, this test was meant to prove the reactor could survive a loss of power. It was meant to make the plant safer. Instead, it exposed that the plant was never as safe as people thought it was. Chernobyl happened because a dangerous machine was trusted too much, because the warning signs were ignored, because the people running the system were trapped inside the system, and because sometimes the disaster is not caused by one person doing something crazy. Sometimes the disaster is caused by everyone doing something that seems barely acceptable at the time, until suddenly it's not, and by then the roof is gone, the air is glowing, the city is empty, and the world is asking the same question: how did this happen?